Activity 9.16 is connections between edges, vertices, and faces. So we've already discussed bases and lateral faces. So if I go ahead and, for example, I will pick what is shown here, which is a rectangular prism. Every single rectangle or square is called a face. Where two of your faces meet, this is called an edge. And all the corners or points where all of your edges meet are called vertices. So for each of your 3D shapes that you created, you want to go ahead and count how many faces, edges, and vertices. So if I do the triangular prism, I'm going to count a top and a bottom base. Those are two faces and three around. So this would have 5 faces. The number of edges then is where all those faces connect. So if I go ahead and count, there's 1, 2, 3 at the bottom, 1, 2, 3 at the top, and then there's 3 connecting the lateral faces. So 3 sets of 3 is 9. The number of vertices, or where the edges meet or the corners, is 1, 2, 3, 4, 5, 6. If I do the same for the triangular pyramid, that one's right here, I will have the bottom face and 3 lateral faces. So there are 4 faces. Edges, I have 3 connecting the base to the lateral faces and 3 connecting the lateral faces. So that's 6 total. And then vertices is 3 at the bottom and the apex at the top. So I counted 1, 2, 3 at the bottom, 1 at the top. That is 4. So go ahead and do all of that for all of your 3D shapes. Okay, so after you have filled out your table, you want to look for patterns between faces, edges, and vertices. A popular one is that for pyramids, it looks like the number of faces, number of vertices are the same. What did we say? Faces and vertices. Like this could be my first one. Why don't you write 2 more? These are your patterns, things that you see in the table. Could be prisms, could be pyramids, could be both. Number 3, so we want to let n equal the number of sides of the base. So a triangular prism would have 3, triangular pyramid would have 3 as n. And now we want to find a general formula for the number of faces, edges, vertices based on prisms and pyramids. So in a pyramid, it looks like the number of edges is 2 times n. So if I go back in my table and I wrote another column where I put in what n was, so n is the number of sides of your base. Now, this is telling me, let's start with the prism, that the number of faces is n plus 2. So that means that this is 3 plus 2. This is 4 plus 2. This is 5 plus 2. This is 6 plus 2, where 2 is the top and bottom base. And then the other numbers, how many lateral faces we have. So this is where we get our n plus 2. The other one that's given to us is that in a pyramid, the edges is 2 times the number of sides of the base. So I'm going to go to edges. I'm going to see that this is 2 times 3. This is 2 times 4. This is 2 times 5. This is 2 times 6. So this is 2 times n. For each of these, you want to go ahead and figure out a general formula. So for example, 4 is the number of faces. Well, right here, it was the number of sides of the base plus 2 because there were 2 bases. Well, here, we only have 1 base, so this would be 3 plus 1. And then the number of faces, number of vertices is going to be the same. Hopefully you see a pattern between 3 and 9, 4 and 12, 5 and 15, 6 and 18, and a pattern between 3 and 6, 4 and 8, 5 and 10, 6 and 12. So you're looking for patterns to fill out this table. Once you have all of these given, there's a number 4, which is another way to connect faces, vertices, and edges is Euler's formula. So this one works for both prisms and pyramids. And let's see, it tells me that the number of faces plus vertices is the number of edges plus 2. Sometimes these are in a little bit of different order, but that's basically what it tells us. So let's verify this, and let's pick our triangular prism. Is it true that faces plus vertices is edges plus 2? So we filled out already in a triangular prism that it had 5 faces, it had 6 vertices, and it had 9 edges. And indeed, 11 is equal to 11. Check. Let's do a triangular pyramid. Okay, I have faces plus vertices is edges plus 2. We also filled out the pyramid one. Faces was 4, vertices was 4, because they were equal. Edges was 6 plus 2, and 8 is equal to 8. Check. So it will work both for prisms and pyramids. Some applications of these formulas are on the last page. So a pyramid has 7 faces. How many sides does the base have? How many edges does it have? So we can try to visualize it. We can try to draw it, or we can use our formulas from the last page. So if it has 7 faces, that would equal the base plus the lateral faces, because it's a pyramid. Every pyramid has 1 base. So if I do 7 minus 1, I will get 6 lateral faces. If you go back, and if it said that 6 lateral faces means the base has 6 sides. Now, how many edges does it have? Well, if the base has 6 sides, we are now talking about this little dumpling, looks like a dumpling, I think, where you have a base that has 6 sides. If I want the number of edges, I will count 6 at the bottom and 6 going around, and it has 12 edges. Edges, I know from the formula, was 2 times n. If n is 6, edges is 2 times 6, which is 12. And the 2n was in that table on the previous page. Okay, I'll let you do B. Let's go to C together. A 3D shape. I don't know if it's a prism or a pyramid, but I know it has 13 faces and 22 vertices. So F is 13 and V is 22. I want to know how many sides the base has. What I know for prism, the number of faces was n plus 2. So 13 would be n plus 2. Subtract 2 from both sides, n would be 11. So if it's a prism, then the base would have 11 sides. So you can either use the formula you came up with on the previous page, or we can try to picture this. So we talked about prisms before. This is a hexagonal prism. So I have to imagine one that has 11 sides, not 6. So I know for a hexagonal prism that vertices are these corner points. right? So I have 6 on the top, 6 at the bottom. So if I were to have 11 sides, I would have 11 vertices at the top, 11 at the bottom. That's 2 sets. So vertices would be 2 times n, 2 times 11 is indeed 22. And I'm going to double check that my number of vertices is 2 times n. So the base has 11 sides. Now I want to know edges. Again, I'm going to use, just as an example, that hexagonal prism again. So the edges is where the faces meet. You have one set on the top, one set at the bottom, and one set connecting all these lateral faces. So there are 3 sets of edges. 3 sets of edges in a prism. So 3 times 11 would be 33 edges. And then you can go ahead and complete part D.